To watch the latest from India Science, don't forget to subscribe to the channel and press on the bell icon to get notifications on all the science-related videos.
Last week, 4 industry giants took a stand against mining our vulnerable oceans for minerals that could help make batteries. What prompted this move? We'll tell you in our first section. In our next section, we'll tell you how human hearts react to weightlessness in space. Hello, Namaskar. I'm Bhagyashree and a very warm welcome to another exciting episode of SciTech. The deep-sea mining industry is keen on extracting precious resources buried in our oceans. But experts have raised concerns, adding that we don't yet understand how mining minerals could affect the oceans and their inhabitants and the climate at large. We'll tell you what deep-sea mining is and why giants like Volvo, BMW, Google and Samsung are against using metals extracted from the deep seas for now.
Climate change is taking a toll on our oceans. Over 90% of excess atmospheric heat trapped by greenhouse gases get absorbed into the oceans. As a result, our oceans are warming up and turning acidic, thereby disrupting marine ecosystems and affecting people who depend on them. Environmentalists suspect that deep-sea mining could pose problems for the already vulnerable oceans. Lying in the bottom of oceans are potato-sized rocks called nodules. They are rich in cobalt, nickel, copper and manganese. The nodules measure a few millimeters to centimeters. These metals can help build batteries for electric vehicles, which is playing a pivotal role in creating a low-carbon economy. Several governments have set their sights on deep-sea mining in the Indian Ocean and Pacific Ocean. The International Seabed Authority, an intergovernmental organization that comes under the United Nations Convention on the Law of the Sea, controls activities on the seabed in international waters. In 1987, the ISA granted India an area of about 1.5 lakh square kilometer in the central Indian Ocean basin for mining. Later in 2002, India surrendered 50% of the land, holding control over 75,000 square kilometer. Ocean mining companies claim that digging metals from the ocean is less damaging than mining on land. In an open letter, Deep Green, one of the mining companies, said extracting metals from the deep oceans will generate zero solid waste, no toxic tailings, and a fraction of the carbon emissions compared to land-based sources. The problem, however, is that we don't know whether deep-sea mining is more sustainable than land mining. The deep ocean is one of the Earth's least understood and least explored ecosystem, which is home to significant biodiversity and also acts as a vital carbon sink. Greenpeace said in a statement, "Many species inhabiting these waters are still awaiting discovery. For this reason, Volvo, BMW, Google and Samsung have backed a moratorium on deep-sea mining." According to the BBC, a senior BMW expert fears that the practice could cause irreversible consequences, she said. Environmentalists have argued that mining could push several deep-sea species into extinction. They argue that it is essential to evaluate the environmental impact of extracting mineral-rich nodules from oceanic depths.
We now move on to another unexplored domain, space. Space is hostile thanks to weightlessness and intense radiation. Scientists are pondering over whether humans would be able to adapt to these inhospitable conditions. According to a new study, the human heart does adapt to space. We'll tell you more in our video.
Some of us dream of visiting space or even living there. But could we survive for long periods in the absence of gravity? To answer this question, NASA designed an exciting experiment. The space agency sent astronaut Scott Kelly to the International Space Station. He lived there for roughly a year between March 27, 2015 and March 1, 2016. His health conditions were compared to his twin, Mark Kelly, who continued to live on Earth. The experiment showed that human health could be mostly sustained for a year in space. It also showed that human bodies adapt to space. Like space, people experience weightlessness while swimming in water. A Frenchman, Benoit Lecomte, swam from Japan to Hawaii from June 5 to November 11, 2018. On average, he swam nearly 6 hours a day, and it took him 159 days to complete the challenging task. Recently, researchers looked at whether long-term weightlessness changes the structure of the heart. They found that long-duration weightlessness, both in space and the seas, causes the heart to shrink. Both Scott Kelly and Lecomte followed a low-intensity exercise routine. While the former worked out for 6 days a week on a stationary bike and treadmill and practiced some resistance activities, the latter swam 6 hours a day, which is considered a low-intensity workout. This suggests that this physical activity could not stop the heart from shrinking. According to the researchers, both experienced a loss of mass and initial drop in diameter in the heart's left ventricles during their time in extreme environments. These adaptations did not seem to be a cause for concern. According to the experts, both men did not show any long-term health effects. Dr. Benjamin Levine, a researcher involved in the study, told CNN, "The function is normal, but because the body is used to pumping blood uphill against gravity in the upright position, when you remove that gravitational stimulus, particularly in someone who is pretty active and fit beforehand, the heart adapts to that new load."
Well, that's all for this episode of SciTech. You can send us your valuable feedback on the email ID flashing on your screens. Also download India Science app or visit our website www.indiascience.in for more such videos. Don't forget to follow us on our social media handles as well. Before signing off, here is Fact of the Day for you.
It is possible to experience weightlessness on Earth thanks to parabolic flight. NASA's Reduced Gravity Flight program flies planes in a series of about 30 to 40 parabolas. When the flight goes up the parabola and descends, passengers can experience microgravity for about 25 seconds.